Okay, good afternoon. It's a pleasure to be here. I'm going to try and give you a bit of a taster about what ESA does. I'm going to try and tell you a little bit about about ESA and education, and try also to give you some examples of how space could be used as a context for STEM. So let's see. So first of all, ESA, the European Space Agency, and it is made up of 22 member state countries. And these are countries that then join together to join their resources together and expertise together for a common goal. And that is for the exploration and use of space for exclusively peaceful purposes. There are ESA sites across Europe. There are 8 of them, 2 in Germany, 1 in Italy, in Spain, France, and the Netherlands. There's a big site there, that's where I work. And it also has a spaceport in French Guiana. There's also another site in the UK, which I forgot about. And over the years of ESA, have been about the last 50 years, over 80 satellites have been designed, tested, and operated in space. Now, unlike many national space agencies, ESA is able to cover all areas of space activities. So that includes space science, so that is going out and looking at stuff in the solar system and further afield, beyond our solar system. Human spaceflight, exploration, telecommunications, Earth observation, launches, as navigation, which you heard about in Pedro's talk, technology, and also operations. And this makes ESA fairly unique. But what is the point of it? Who benefits from it? And there's we all receive TV broadcasts. We have good data access, we have navigation and weather forecasting. It's good for our economy. It benefits our economy by providing new services and jobs, and creates new jobs are created in things like transport, health services, agriculture, manufacturing, and civil services. There's a benefit to our planet. We're able to provide near real-time data of the Earth and its climate. Also the future. Space can inspire millions of young people across Europe and the world, in fact, to embrace careers in technology, in the sciences, and in engineering. So, now ESA has an education area. So education in ESA is a mandatory activity. That means that every single country that is a member of ESA has to contribute to education. And the objectives of education at ESA, I'll just read this, is to motivate and enable young people to enhance their literacy, competences, and skills in sciences and technology, or STEM disciplines, inspire and enable young people to consider pursuing a career in STEM, in the space domain in particular, of course, and to contribute to increase youngsters' awareness of the importance of the European Space Programme, space research, exploration, and application in modern society and the economy. So it is a unique motivational context for the study of STEM subjects, and ESA is a source of unique and multidisciplinary scientific knowledge. And it also provides access to space data facilities and experts. So the target audience for ESA education is actually very wide. It covers from the very early years in education, from 4 all the way up to university. So it has 2 programs, one that provides for primary and secondary level education, and one that provides for tertiary education as well. The challenges are that there are a lot of school-age students, a lot of teachers to try and reach, and we have 22 countries, also with 18 different languages, and even within each country there are often different educational systems from region to region. So it's a challenge. This is one of the benefits of the ESERO project, in which they are offices that are run in a country and can provide educational support or support to educators, and that in a way that fits their needs in that country. One of the other challenges also is the lack of interest in STEM, in particularly for girls. And these are things that need to try and address. And there is also a shortage of specialised workforce in the space sector. Now, another challenge is to look ahead to the future. So in a number of years' time, there will be jobs around that we don't even know exist yet. So we need to prepare the workforce of the future for these jobs that we don't even know what they might be. So this is something else that we need to do. There are challenges in our society at the moment: climate, resources, energy, health, and safety. And all these things can be addressed through education to try and change the mindset, perhaps, of young people. So when they go forward into their lives, they think about things differently. Things aren't infinite, they're actually finite, and we need to kind of have a different attitude. Okay, so primary and secondary education. Some of the things that we produce at ESA, we have these resources called, that are a series called Teach with Space, and these are classroom resources. They're all available on the website. There are some links in the slides later. And as I go through in a bit some very specific space context, I'll try and tell you which resources tie into this topic. And you heard about those school projects and challenges. I just put 3 examples up there from Stephanie this morning. Some of these Teach with Space resources have been developed to support the challenges for stuff that could be done in the classroom if you're working on one of the challenges or projects, or they could be done standalone. We have these ESERO offices, of course one here in Ireland, and they cover 17 different countries, and we have interest from many other ESA member countries as well. And these are a really important offices because they can work at a national level and provide for the needs of teachers there. Okay, so, right, we're all explorers, okay, we're all going to explore space together, and we have the challenge of exploring the universe and improving life on Earth. When I say we, this is us, it's all the countries that belong to ESA that contribute to the European Space Agency. And I'm going to talk about some kind of context and give you some examples of how some of these contexts might fit into the classroom. So, first thing is, we've got to get into space somehow. And launching rockets is one of the things that ESA does, and there's a spaceport in Kourou in French Guiana. And so ESA has a little family of rockets. There's a couple of examples here. And they take the different satellites up there into Earth orbit. Now, with a rocket, rockets need a fuel, they have propellant, and the chemical energy of the fuel, the propellant inside the rocket, converts into work and heat energy during the launch to get up there into space. Now, once you're in space, what are we going to do there? If we might want to look out into the universe. ESA has a range of telescopes that look out into the cosmos, and it covers they cover nearly all the parts of the electromagnetic spectrum. This is actually a poster. I'll make sure that you have the link so you can see it a bit more clearly. And in here you can see there is a number that are operational at the moment, and the next, and towards the top of the picture, these are the ones that are in the process of being developed. And at the bottom, they're called the legacy missions. These are the ones that are no longer in operation, but they've collected so much information about what's out there that they still make a contribution to astronomy. Now, I'm going to just focus on one part of looking outwards, out into the universe. And I know that some of you today went to a session about the exoplanets. That's right. And so I'm going to just pick up on this theme a little bit. And it's an exciting topic to engage with students. And if by learning more about exoplanets, we could further the understanding of our solar system and how it formed. And there's also the intriguing question about whether we are alone in the universe. Now, the first confirmed detection of an exoplanet, a planet orbiting another star outside of our solar system, was the first confirmed detection of an exoplanet orbiting a sun-like star was actually only in the mid-1990s. Now, in a relatively short period of time, I guess it kind of depends on how old you actually are. For students, it would seem like a long time ago, but in this short period of time, around 4,000 exoplanets are now known. And so this is quite an up-and-coming science. It's sort of emerging into needing new expertise as we learn more about these individual planets. And to learn more about the planets, there have been a number of missions. There's been some space missions that have gone to discover these exoplanets. There are also telescopes on the ground. There are surveys that look into the sky and detect these planets orbiting around these stars, which is a very difficult thing to do. But there's a new mission from ESA that's going to launch within the coming months. In fact, it should have launched between sort of middle October to the middle of November, but I understand that it's now being pushed to December. It's called KOPS, and that stands for the Characterizing Exoplanets. It's going to look at stars where we know that there are exoplanets orbiting around them, and it's going to look for these exoplanets, and it's going to take even more information about them so that we can actually learn about the planet itself, not just about the planet, but also about the star that they're orbiting. And so now, in the terms of looking out there for these exoplanets, in the mid-90s, people weren't even sure that they existed. It perhaps wasn't taken very seriously. But now they're there, we need to understand what they're like. Could they be similar? Could there be any that are similar to Earth? Could there be places and environments that could be suitable for sustaining life? So KOPS will be launching very soon. It's actually a very small satellite, and it's going to look for a transit of an exoplanet. And a transit is where, if you look at a star, you see the planet goes across the face of the star. So as you look at the light coming from that star, it appears to dip very, very slightly, and then from looking at the change in brightness of the star, you should be able to it should show that there is a planet orbiting it. And if in our solar system we see transits of Mercury and transits of Venus, so the ones that are the inner planets, and if you imagine that Venus against the sun looks like this tiny dot, it's very, very difficult to see, and Mercury is very difficult to see. Imagine trying to do something like that, but it's 50 light years away. It's very, very difficult. So KOPS is going to make follow-up observations of places where there are known to be transiting exoplanets. And there's a new resource that will also come up out in the coming months, and this is called Exoplanet Detective. So it's about exoplanets, but actually in the resource or in the activity, students design a model to detect an exoplanet using a transit method. And there is a setup that's given. I mean, your students are able to go and create their own kind of experimental setup. But the basic setup is a shoebox, a light sensor. It could be a light sensor on a mobile phone app, and a light source, a cocktail stick, bit of Play-Doh, and then you can put simulate the planet going across the star and observe the dip in the light. But this, in the activity, it's about designing an experiment It's about learning how to use the equipment and also developing skills for interpreting graphs and interpreting data. That's coming soon. Now, by studying alien worlds, we can place our own planet in context. And we're going to come back into the solar system now. So another thing that ESA does is launch uncrewed missions, robotic missions, satellites that go and explore various objects in our solar system. Maybe you heard about Rosetta that visited the comet 67P, and that's one example. There have been missions to go to the Saturn system, that's Cassini-Huygens, so that was a joint mission with NASA and also the Italian Space Agency. There was a mission that was orbit around Venus called Venus Express, been to Mars. There's a mission on its way now to Mercury called Pepe Colombo, and that launched last year, but it will take 7 years to get there. But I think in the coming, it could be even within the next year, the coming months maybe, it will fly past Venus. So hopefully we'll be able to see something from there, because when these satellites are en route to other places, they take the opportunity of passing other passing objects to maybe test their cameras and instruments. Let's see. And then we're going to I'm going to focus on the Mars actually, and I don't know how much you've looked at Mars during the day. No? Okay. So it's a popular planet. It's always, people have had a long fascination with it, and there was a time before spacecraft went there that people generally thought there might be intelligent life living there. And I think that there was the War of the Worlds, there was on a radio play, and I understand that some people tuned in late and missed the beginning, and it caused a lot of panic because people really believed there was going to be an invasion by Martians. So it's had a long fascination. But then the first spacecraft flew past the planet, and there was no sign on its surface of any kind of intelligent life or structures. Since the 70s, since the first spacecraft flew past, has been really well explored. And ESA has a mission that's been there for 15 years, or more than 15 years. It's called Mars Express. And it's taken some great pictures of the surface, and it's also made some amazing discoveries about the planet. And it's an orbiter. It's orbiting around Mars. And now Mars, as the spacecraft images show, is seemingly very dry, barren kind of place. No signs of life. Some big volcanoes, some deep canyons. But by understanding more and looking at these features on the planet's surface, and combined with the information sent by the rovers and missions that have landed successfully on the surface of Mars, they've been able to find evidence that water once flowed on the surface, and there are minerals that wouldn't be there without water, and there are features that look like channels, river channels, that have been found on the surface and pictured by these spacecraft. So in the past, it's thought that in the past Mars was much warmer and wetter, and had a much thicker atmosphere. And at some point over the course of history, it's lost its atmosphere, and it's become cooler and much drier. But there is water on Mars. There's water in the form of ice. So Mars is fairly cold, and there is ice on Mars in the form of frozen carbon dioxide. It also has frozen water on the surface. And recently, in the last year or so, Mars Express has one instrument that's a radar that looks underneath the surface, and it found evidence of a lake of water underneath the surface of the planet. And this is quite exciting. So there's probably still water, liquid water, not on Mars, but underneath the surface. ESA's going back to Mars with another mission. ExoMars, it will be joined by the Mars Express will be joined by the ExoMars program, and one of the program consists of 2 missions. One is an orbiter called the Trace Gas Orbiter, and that was launched in 2016. That's already there, orbiting around Mars, and it's going to look at the different little bits of different gases in the atmosphere. And the Trace Gas Orbiter will soon be joined by a rover. This is the ExoMars rover. And these missions, the ExoMars program is a joint mission with the Russian Space Agency. And so, one of the other things that Mars Express managed to detect around Mars was the presence of methane. And methane doesn't exist in the Martian atmosphere for very long. Therefore, it must be being produced somehow. And it's unclear at the moment whether this is a geological, the source of this methane is geological, or perhaps this source could be biological. So that's not known. The ExoMars rover will, when it lands, it will look beneath the surface. It will have a drill that will drill down around 2 meters, take samples, and it will look for the signs of probably a past or present life. So, well, let's see. That's due to launch next year, and it will take around 6 months, 9 months to get there. And so, hopefully, let's see what happens and see if it can find any signs for life there. So, if we go to other planets and we want to look for life, how are we going to do that? We have to make some assumptions. Because if you think that life could be anything, but you can't really look for something, you don't know what you're looking for. So when we go there, we need to make the assumption that we're looking for microorganisms, or when we look for life in general, or their past existence, and that we're mostly looking for water-based life. Now, Mars, if we think about Mars, it's a harsh environment as it is now. It's fairly low temperature, low atmospheric pressure, and it has, if you're on the surface, you'd be exposed to high doses of radiation. But could life exist there? If it lives underground, it will still be living in very difficult conditions away from sunlight. Well, the more that scientists look for life on Earth, the more that they find. And life on Earth has adapted to an extraordinary variety of conditions, and conditions that humans had considered to be inhospitable. Now, this life that can live in very extreme environments, maybe very cold places, very dry places, excuse me, one's under high pressure, or maybe in acid, highly acidic water, they are not thought to have developed in these harsh environments, but they're thought to have adapted to it. And these organisms are called extremophiles. Excuse me. And these are microorganisms, and they can be single-celled or multicellular. And if this extreme life has been found on Earth, could it exist elsewhere? Could life have started elsewhere in the solar system and then adapted to different conditions, like the harsh conditions on Mars? I'm really sorry. So, I'm not saying there is life out there, but because at the moment we've found no evidence for it. But it's worth taking a look now that we know that it can survive in these environments. So I just want to point out 2 resources just here. So these resources, one is called Can Life Survive in Alien Environments? And this one actually, it's more of a discussion-based activity in it. It's kind of the idea is to get students thinking about the possibilities of life, and they look at extremophiles and the variations that they have, that you have here on Earth. Look at environments out there in the solar system, and try and see, well, could this, if there was life out there, could these weird kind of lives survive in these weird kind of conditions? And of course, you know, there's no real answer to that, but it's to get thinking and trying to make some logical conclusions about what might be possible. And actually, I was going to pick up on something that Pedro had said about the aliens, and he asked you about if there was a signal sent. Is that right? You asked about the signal being sent. What would you do? Well, one of the things that, you know, the discussion points in this resource is, if we found life, does it matter anyway? What should we do? Would it change if we find microorganisms living somewhere? Would it change our lives? Is it very significant? If we found life on Mars, though, and you've probably heard that people, space agencies around the world want to plan to take people to Mars one day. If we do find evidence of life on Mars, should we send people there, or should we just leave it alone? So this activity wraps up with some that sort of discussion. The other one is called Space Bears, and it's one about tardigrades. Now, if you heard of tardigrades yet? So these
they're on the moon now.
Bear things, but
They're now on the moon.
no. So these little creatures are amazing. They're not extremophiles. So an extremophile is something that thrives in an extreme environment, but these tardigrades go into a special state where they shut down and they survive. They're survivors, and so they're on the moon, but they've also been taken to space and exposed to the vacuum of space, exposed to the coldness, the high temperature, and they then retrieved after being left there for some time, and they've been able to revive them. So this resource actually is about, you can find tardigrades in wet areas like mosses and things. You can go and collect some samples, extract these tardigrades, and then experiment on them. That's the idea behind the Space Bears. Okay, so now, as well as going to looking into the solar system, exploring the solar system, and exploring, looking out of our solar system, it also sends satellites, or launches satellites up there to look back down on our planet. And ESA has been, it launched, it's been had a wide range of satellites launched over the last 40 years to look back down on our Earth. Some of these have been weather satellites, other of these have been there to try and build up a picture and understand the complexities of our planet, and particularly with how things change on a global scale. Satellites in space looking down are in a good place to be able to do that. And they are now, so they are used then to forecast weather, which I've mentioned before, and help answer important Earth science questions, provide support for agricultural practices, maritime safety, help when disaster strikes, all these kind of things. So there are many different satellites, and there are lots of them. There are ones that the weather satellites. There's the Copernicus program, which includes a family of satellites called the Sentinels, and they provide really vital information about natural disasters on the Earth and much more. And then there are also some that's here it's marked as science, the ones in green there, and these are missions that are launched to test out new ways of finding information out about our planet. And there's one called Aeolus, which looks at the wind speed. It's got a special detector to look at the wind speed at the top of the atmosphere, and this will help to even to improve further weather forecasting and such like. So we observe the Earth for life on Earth. They can look at the air quality of our planet, and this is something that's very, very important to everyone in our lives. I live in the Netherlands, and there's a very, very populated, in a very, very populated part of Europe, and the air quality, as a result, even though a lot of people cycle, is very, very poor. It's very, very poor. There's also they grow a lot of flowers in the summertime. There's a lot of pollen around, but we can look at these from space, and this is really important to help improve our daily lives. And these kind of emissions have data that is available and free, and for everyone to download and use. And I forgot to put the link in there, but there's a web link, site called the EO browser, and there you can find and access satellite data. And the website itself was made independently, without education in mind necessarily, but they now work with us to help, so we can make it a little bit more user friendly and fit to what might be useful in the classroom. But you can go on there and try and find your school, your local environment, look at the satellite imagery. Maybe there's ways of doing experiments locally in your local area, and you could maybe compare the two bits of information. So I'll add the link if that's okay.
That would be great. That's really.
And there's another app as well which I've forgotten. It's about a Copernicus one, and I'll add that in as well.
And just EO is Earth observation, Rebecca.
I think it's if you just put EO browser, you should be able to easily find it.
Thank you.
And then there's a couple of resources that have been produced. One called the greenhouse effect and its consequences, and also the infrared webcam hack. And these are linked to Earth observation and looking at how, understanding how we can observe our planet from space with little cameras using infrared radiation, and also the consequences of the greenhouse effect on our climate. Or changes to the greenhouse effect on our climate. So, another example when we look at observing the Earth is we can look at disaster areas or natural disaster areas or fires or whatever it might be. So we can look at flooded areas, and this can help. This is quite important for helping to manage an area after there's been a natural disaster. They can use the satellite information to work out how to plan evacuations or support the needs of this particular area. So disaster management and the highways of the ocean. I just mentioned that one. It looks at global ocean currents, and that one actually uses tools available on the internet to collect satellite data. The other one, after the storm, it's about understanding the impact of extreme weather, or that extreme weather can have on society, and how Earth observation can be used to track incoming weather and assess the damage caused by extreme weather. So this information from space helps us to understand our home planet. It delivers information on a global scale about key scientific questions, oceans, about climate change, the environment, and help people like us on Earth. This picture here was taken this week, and it's the big typhoon that was going to due to make landfall in Japan. And I think it's called, I have it here, called Hagibis, the typhoon. Yeah, is that how, I don't know how you say it. And so it was expected to make landfall over this weekend, but being able to predict this kind of weather, especially this sort of scale of bad weather, it helps us to plan in advance, and even if it is for travel and our leisure. We were talking at lunchtime about rugby and matches being cancelled and things like that, but they were able to do that in advance to make sure that everyone was, in the first instance, safe, and make sure that other games could continue, etc., etc. So this typhoon, it was compared to a a Category 5 hurricane, sorry, and it was captured by the Copernicus satellites called Sentinel-3. And the eye of the storm is about 60 kilometres, to give you an idea of the scale. Pretty big. Right, so we've looked at launching to space to look out into the universe, to explore our solar system, and then to look back down on our planet Earth. And but we also take people. There are people also going up into space. So we have an outpost in space for people. This is the International Space Station. There are 6 people living and working in this environment. And on the International Space Station, at the moment, there is this guy here, Luca Parmitano. He's an ESA astronaut. He's currently the commander. Launched there on the 20th of July. And his mission is called Beyond. You can read more about it. I was going to talk a bit more, but I might have to skip this. He's going to do, I picked 3 things to tell you about. He's going to, whilst he's up there, do some testing for future exploration missions when we will go beyond low Earth orbit. And he will be remote controlling a rover that's here on Earth, and it's going to be, I think, in Lanzarote, so like a moon-like landscape. And he's going to be testing out this sort of remote control access from an astronaut. The Earth benefit of this actually is that these kind of systems could be used to help people on Earth go into environments that aren't safe. Perhaps again thinking back to disaster zones, to other areas where we can't send people, we can use robots instead. He will also be has taken up there's an experiment called BioRock. And so this is about microbes that are able to extract minerals from the surface of rocks. So these microbes are like microscopic miners. And this again is a science that is for the future of exploration, taking people further, because microbes are could be used to generate food, they could be used to generate water. And when we go to space in the future, you can't, it's expensive and inefficient to take stuff from Earth, water, food, materials, with us. It's better that we can go there and use what's around, recycle, and make it a sustainable existence for people who might live perhaps in the future on the moon. And so one other aspect of this is the life support, right? This is Alexander Gerst, this other astronaut in the little picture. That's not the same guy, but this was Alexander Gerst was installed this life support system that's being tested on the International Space Station, and the idea of this is to recycle carbon dioxide into breathable oxygen. But we could go forward then to the moon, perhaps in the future. And in fact, ESA and countries all around the world are working towards this. And they will. This picture here is of a spacecraft called Orion. That's actually a NASA vehicle that will take humans deeper into space, perhaps next year. And ESA provides the Europe service module to Orion that contains the propulsion system, the power and life support. And it will go in the future to a gateway, which will be a humankind's most distant outpost. So this gateway is intended to be assembled around the moon, and it will provide astronauts a post, a place from which they can go to the lunar surface. And the idea is this will be in the mid-2020s, in the very near future. That's what the planning is for. So we're learning about how to performing experiments to enable astronauts to go and live independently on the surface of the moon, or maybe even further beyond. Thank you.
Thank you, Rebecca.